More than 50 years ago, Apollo 17 left tracks in lunar dust, marking humanity's last visit to the moon during the historic space race era. That mission in 1972 ended the Apollo program after 12 American astronauts had successfully walked on the lunar surface during 6 separate missions. The original space race was driven by Cold War rivalry between the United States and the Soviet Union, competing for technological dominance. The Soviet Union achieved early milestones, launching the first satellite, the first animal, and the first human into Earth orbit. In 1969, however, the United States landed Apollo 11 astronauts on the moon, winning the defining moment of that geopolitical competition. After Apollo 17, lunar missions stopped primarily because of high costs and shifting political priorities within the United States government. President Richard Nixon concluded that America had already demonstrated superiority and redirected funding toward other national and space initiatives. Focus moved toward satellites, space shuttles, and eventually the International Space Station, instead of continuing costly lunar surface expeditions. Meanwhile, China quietly developed its own lunar exploration program to expand technological capability and international prestige. In 2013, China successfully landed the Chang'e 3 robotic spacecraft on the moon, the first soft landing since the 1970s. Chinese officials have openly described lunar exploration as a symbol of national strength and long-term strategic ambition. China has stated its goal to land astronauts on the moon before 2030, signaling serious commitment to human exploration. The United States responded by accelerating plans under NASA's Artemis program to return astronauts to lunar orbit and surface. Artemis I launched successfully in 2022, sending an uncrewed Orion spacecraft around the moon and back to Earth. Artemis II aims to send astronauts on a lunar flyby, marking the first crewed lunar mission in over 50 years. Artemis III is planned to land astronauts near the moon's south pole no earlier than 2027. Unlike the 1960s, today's missions prioritize safety, sustainability, and long-term presence over rapid geopolitical demonstration. Modern spaceflight operates under stricter engineering standards and public scrutiny, slowing progress compared to Apollo-era urgency. NASA developed the Space Launch System rocket to carry astronauts beyond low Earth orbit toward lunar destinations. Private companies such as SpaceX and Blue Origin are building landing systems and supporting technologies for Artemis missions. Public-private partnerships aim to reduce costs, but have also introduced technical complexity and schedule delays. China is developing its own heavy-lift rockets and lunar lander systems, independent of American infrastructure. Both nations envision establishing permanent or semi-permanent bases on the lunar surface. The moon's south pole is particularly attractive because permanently shadowed craters contain frozen water ice. Water is essential for drinking, breathable oxygen production, and manufacturing hydrogen-oxygen rocket propellant. Extracting water locally could dramatically reduce the cost of deep space missions. Hydrogen and oxygen derived from lunar ice could refuel spacecraft for missions to Mars and beyond. The Artemis Accords, led by the United States, have been signed by around 60 partner nations. These agreements outline principles for peaceful exploration, resource use, and transparency in lunar activities. China leads a parallel initiative known as the International Lunar Research Station. Russia and several other countries collaborate with China on their lunar research framework. This emerging alignment reflects broader geopolitical divisions extending beyond Earth into space. Experts argue that being first to establish infrastructure in resource-rich regions provides strategic advantage. The moon is vast, but only limited areas contain accessible resources like water ice. Permanent installations could influence access and operational zones for future missions. Unlike Apollo, this race is about sustained activity rather than symbolic first achievements. The objective now is long-term utilization rather than a single historic landing. Helium-3, present in lunar regolith, is sometimes cited as a potential future fusion energy source. However, extracting and transporting helium-3 from the moon remains technically unproven and extremely costly. Any economic return from lunar mining would require substantial technological breakthroughs. Despite uncertainties, both nations view the moon as a stepping stone toward Mars exploration. NASA frames Artemis as preparation for eventual crewed missions to the Red Planet. China similarly describes lunar development as part of its broader space power strategy. Space remains inherently dangerous, involving massive rockets fueled by highly energetic propellants. Apollo missions succeeded partly due to calculated risks that would be unacceptable today. Modern programs emphasize redundancy, testing, and risk mitigation to protect astronaut lives. These safeguards contribute to slower but potentially more sustainable progress. Geopolitical competition continues to influence funding decisions and national priorities. American officials have publicly stated they cannot afford to fall behind China in lunar exploration. Chinese leadership emphasizes peaceful development while pursuing technological self-reliance. The outcome of this renewed competition may shape future norms for space governance. Establishing early operational presence could determine who sets standards for lunar resource utilization. The new space race involves governments, private industry, and international coalitions simultaneously. Commercial companies are expected to provide transport, cargo, and infrastructure services. Success depends on integrating rockets, landers, habitats, and resource extraction systems cohesively. Unlike the 1960s, today's strategy connects multiple missions into a sustained architecture. The goal is not merely planting a flag, but building lasting capability beyond Earth. Whether the benefits justify the enormous investment remains an open question. What is certain is that humanity is once again preparing to return to the moon.